Hey guys, welcome to the next data structures tutorial. Today we'll be covering stacks and single linked list. So let's get started. First thing, what are we going to learn today? Alright, so these are the list of topics that we will be covering. First is what is linked list. Then we'll learn about different types of linked list. But what we'll be studying today is only single linked list because the topic is vast. So we'll cover only one aspect today. Then we'll learn about what are stacks, then different functions of stack and applications of stack. So let's get started. First thing, we'll do some revision of what we have learned till now. So we have learned that data type can be categorized into two types, that is linear data type and non-linear data type. So array, queue, stack, linked list, these are the different types of linear data type. Alright, now we'll start with the linked list. What is the definition of linked list? Linked list can be defined as collection of variable number of data items. What it means is a linked list doesn't have a fixed number of data items present in it. And the second point is every node of linked list consists of two items, that is data and reference to the next node. The second field of the list must be a pointer type, that is it must be pointing to the next address. Alright, now there are three types of linked list, that is single linked list, double linked list and finally circular linked list. Today we'll be only covering single linked list. So this is the basic type of linked list. And what happens in single linked list? Every node contains the address of the next node, as you can see over here. Second point, it is unidirectional, that is you can go only in one direction. And the last node has the next address as null. Okay, so the last node is pointing to null. So this is the basic idea of single linked list. We'll look at an example so that you'll understand the concept much better. All right.
For example, let's say we have got a train over here and there is a ticket conductor who is checking each and every person's ticket. Okay, so he's checking first person ticket in the first compartment, then second person and so on. And now he has to go to the third compartment. So when he has finished checking tickets in the first compartment, he can't directly go to the third compartment. He has to go through the linked area from first compartment to second compartment and second compartment to third compartment. He can't just fly from one compartment to third compartment, right? So this is what linked list is like. What you have to do is you have to go from first to the next one, that is linked content, and then only you can reach from one place to another.
Now the code for single linked list is represented like this. So let's say we have got struct node, that is what is present inside the node. First we have the data, and the data type for data is integer, and the next struct node is star next, that is the address of the next node. Okay, so this is the basic structure we write in code. Alright, now let's look at some of the operations that are done in single linked list. The common single linked list operations are searching. So basically if you want to search for a specific node, then it can be determined if the data is present in the list or not. Okay, you can search through the entire list and you can find out if it is present or not. The second operation is traversing, that is you are going through each and every node at least once in order to perform specific operation. Okay, so this is the meaning of traversing, going through the entire linked list and every node at least once. Now we'll learn about the advantages and disadvantages of single linked list. First, the advantages. Alright, so it is one of the easiest data structures to implement. Second advantage is that the allocation and deallocation of memory is done very easily. And the final advantage is that it saves memory wastage. Okay, now what about the disadvantages? First one is it uses more memory compared to an array. Second disadvantage is that it requires more time to access elements because it has to go through each and every element no matter what if you want to search for an element. And finally, the reverse traversing is not possible. Okay, so these are the three disadvantages of the single linked list. Alright, now what about stacks? So let's look at the definition basically. Stack is an abstract data type that holds an ordered linear sequence of data item. Okay, so this might sound confusing, but imagine a stack of papers, that is a paper above another paper. That is what a normal data stack also can be imagined as. Okay, so basically you have got multiple data items on top of each other and the last element added is at the top of that stack. It is called a last in first out or LIFO, or first in last out or FILO type of data structure. Why? Because the last element that is added inside the stack is going to go first outside the stack because it has the top, and first in last out means the item that is inserted first inside the stack is the last one that is going to come out of the stack at the end. Insertion and deletion is only performed at the top of the stack. So this is the reason it is called LIFO or FILO type of data structure. Alright, now we look at an example so that you'll understand this concept much better. Okay, now implementation of stack uses two primary functions. First one is called push function and the second one is called pop function. Now what happens in push functions? So for push operation, we need to avoid overflow condition. And for pop operation, we need to avoid underflow condition. Now each of these conditions, the meaning of that we'll understand. Okay. So let's say you have got a stack and you want to add a new element. That adding of new element is called push operation. Okay. So let's say your stack is completely full. Okay. And you want to add a new item. If you try to add a new item, it is not going to go inside. It's like when you have got a glass full of water and you try to add more water to it, what is going to happen? It is going to overflow. This is exactly what you have to check for, whether the stack is full or not. So checking for overflow condition means you have to see whether the stack is full or not. If it is full, you cannot add the new element or you cannot perform the push function. That is the meaning of overflow condition. Alright. Now what about pop operation? So pop operation means if you want to remove a number or some data from the stack, that is called as pop operation. That is removing an element from the stack. So what happens if your glass of water is completely empty and you want to remove some more water out of it? Is it possible? No. So that is exactly what underflow condition means. Let's say your water tank is empty and you're still trying to remove some water with your pump. You're not going to get any water out of it. So it is called underflow condition. So basically, if your stack is empty and you're trying to delete some element, it's not going to work, right? So pop operation is basically deleting an element. Push operation is inserting a new element. But you cannot delete something that is not present. So that's why you have to check for underflow condition. Alright. Now there are following functions that we can learn or we can perform to check the status of the stack. First one is called peak or top. The second one is called is full. And the third function is called is empty. Okay. Now we'll learn about the different applications of stack. First, you can use a stack for string reversal. Then you can do undo or redo operation. Then we have got recursion. The fourth is depth first search. Then we have backtracking, then expression conversion and memory management. So these are some of the applications of stacks that we can use them for. Now let's look at the conclusion of today's tutorial. Linked list and stack are non-primitive linear data structures. Each node in single linked list contains one data field and one pointer field. Single linked list is used for dynamic memory allocation. That is, you don't have to define the number of elements that are going to be present at the beginning itself. You can add more elements also, and it has variable number of data items. And in stack, push and pop only occurs at the top. Stack can be implemented for both static and dynamic allocation. So that's it for today, guys. Thank you very much.